Now we will start the class example 25. So for 25, it's kind of the opposite of class example 23. So for 23, we started from streamflow and found the unit hydrograph. For 25, we will start from the same unit hydrograph and we will try to find the streamflow for the same area. But one difference between class example 23 and 25 was for 23, we had only one storm, but for 25, we have again three storms, like consecutively three storms with that 4 hours lagging in between each storm. And at the same time, that unit hydrograph, that one was for 1 millimeter of runoff depth, but this time for each storm, we have 3 different runoff depth. So it's like for this 3 kilometer square area, we have the unit hydrograph. Then on a single day, we got 3 different storm with 3 different intensity, like 3 millimeter, 7 millimeter, and 5 millimeter. So the question is, after these 3 consecutive storms, what will be the stream flow? So if you can remember, in lesson 31, we discussed a little bit about the use of unit hydrograph, and we said that if we know the unit and if we know the change equivalent runoff depth, we can actually get the we can find the different value for the stream flow and unit hydrograph. So it will be something like that. We have one single unit hydrograph, and for each storm, since we have different equivalent runoff depth, like for this one it's 3, the next one is 7 and 5. So basically for the second one, we will just multiply with this number to get the second runoff and everything, and then we will find, like after end of these 3 consecutive storms, what will be the total stream flow. Okay, it's the same data set and we are using the same unit hydrograph, so we don't have to read the very first line. Let's read the second line, what we have to do for this class example 25. Using those unit hydrograph ordinates, determine the hourly ordinates of daily stream flow after 3 storms for this drainage area. Equivalent runoff depth, it is one for unit hydrograph, but it has different one. For each storm is given below, and given that each of these storm is lagged by 4 hours, just like the previous class example. A constant base flow of 60 cubic meter per second has been estimated. So here we had different base flow, but for this question, they already told a constant base flow of 60 cubic meter per second has been estimated. So we have to find what will be the stream flow after these 3 consecutive storm, and the calculation procedure will be exactly opposite. Okay, so we will start from unit hydrograph and find the stream flow. So let's work with the very first one. So these ordinates, that is actually for 1 millimeter of runoff depth. For this one, it has 3 millimeters. So what we have to do, we will multiply each value with 3. Okay, and we will calculate this one here. So that is like 41.65 multiplied with 3, 124. Now the next storm, it started after 4 hours from the first one. So all the value will start at 4 hours, and that is the unit hydrograph. What we will do, if you look at this one, we are using this column multiplied with 7. This will be a common mistake when you will do the calculation for your test or your homework. Some of you will use this column, that is not the right column. That is the first storm, and that is the unit hydrograph for this area. So we have to always use the unit hydrograph. Okay, so for this one, we are multiplying the 7, and if I do that, that is all the numbers. For the third one, it is 5 millimeter. So we have the data for 1 millimeter. We will just multiply by 5. And if we do the same calculation here, we will have this value, right? So if I multiply 3.06 with 5, we are getting 15.31. Now, after all of these three, we have to plot these 3 storms in one graph. Okay, we can obviously do that, and I actually did that. So this one, if you look at here, that is the first one, then the 7 times, sorry, that is the first one, which is already 3 times higher than the original one, then the 7 times and the 5 times. And you can see at any hour, we can have either 1 storm, 2 or 3. Okay, so for hour 4, we have 2 storms, but at hour 8, we have 3 storms. So basically, we will add all of these. Oops. So that is all the value here. And we need this value as well. So this is the direct runoff hydrograph coordinates. Now we know when we add base flow with direct runoff hydrograph, we can get the stream flow. And we already have the base flow, which is 60. Okay. And here we will add these 2 columns, and that will give us the stream flow. So from this unit hydrograph, after 3 storms, what will be the stream flow for this area? We can get that, and if I plot that again, this is the stream flow hydrograph. Okay, again, since this one is not the measured one, rather the calculated one, that's why we didn't get a very smooth shape, but we got the general shape of hydrograph. And you see it didn't start from 0 because we have 60 cubic meter per second flow as a base flow, and after that all the runoff for 3 different storms. So that is the end of class example 25, and that is the end of lesson 31. Thank you for watching this video.